Hey, kiddos. How's it going today? Good? I love talking to myself. Not really. I hate it so much, and I want you guys back here so badly. Okay, but anyways, okay. So we are just gonna finish up this packet. Like I said, tomorrow we're gonna kind of like iron out some details, all that jazz. Yeah, and then we'll figure out what to do for the rest of the time. I just want to see where we are tomorrow. So we just have 2 more examples left to go. Whoop, whoop. The first one, number 4. We're still going to do the same things that we've been doing, okay? Find the intercepts, the holes, asymptotes. So the first things first, your x-intercept. Hi. I don't know why it's coming out all grainy looking. It does look grainy. I don't know why. Anyways, okay. So we've seen from the other ones, it's really just setting the numerator equal to 0. And when you solve this, divide by -4, you still get 0. So x would be 0. Okay. Now, if x is 0, the x-intercept is 0, then the y-intercept is going to be 0. But let's double check that bad boy. So if I plugged in 0 in for the x, so I do get 0 on the top. -2 times a +4 on the bottom is -8. So we do get a y as 0. Yay! So 0, 0, that's the x and the y-intercept. They end up being the same because it's the origin. Cute. Okay. Now this one is already factored for us on the bottom. You're welcome. But we can't cancel with anything on the top. So there's no holes. So now we got to check out the VA. So the vertical asymptote is anything that's left over on the denominator. You set equal to 0. Boop, boop. X equals 2. X equals -4. So at 2, there's a vertical asymptote. Vertical just means straight up and down. -4. It's also another vertical asymptote. Boop, boop, boop. Cute. Okay. Yeah. So now we have to go into our horizontal asymptote, our ha. Okay. Now for this, you would want to expand the bottom into standard form. So if we would like double distribute, like the x goes to the x goes to the 4, and then FOIL, if you will, we would get x squared plus 4x minus 2x minus 8, which just becomes -4x squared, all over x squared plus 2x minus 8. So for the ha's, we got to compare the degrees on the top and bottom. So the degree on the top, remember, it's always just the highest exponent. That's 2. The degree on the bottom is 2. So for this ha, since they're equal to each other, I don't know, I'm trying here. We take the leading coefficient of each of these, which for the top, it's -4. And for the bottom, it's 1, and you just divide them. So we have a horizontal asymptote at -4. 1, 2, 3, 4, down, boop, 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 boop. Cute. Yeah, and since it has an HA, there's no OA, there's no SA. No essays anyway in math. And then we can graph. So looking at this, because there is only one, one x-intercept, these should be going upwards here. And again, because there's no x-intercept, if we're looking at the other two sections, like the section on the right here, and the section on the left right here, since it will not cross the x-axis, then it will be down below instead. Now, if you wanted to just double check that, you can plug these in. Like you could plug in a number past -4. So if you plugged in -5, let's say, into the original. -5 minus 2 times -5 plus 4. So let's see. Positive 25 times -4 is -100. And the bottom, -7 times -1 is a +7. So this is like, I don't know, negative. Let me see if I can do this. 4 point something. Okay, so yeah, it would go pretty far down here. So yeah, that's accurate. And you can plug in 3 into the original equation, see what that gives you. And you can plug in anything in here as well, just to make sure that it's an accurate depiction of your graph. Cute. Okay, my loves, last one. So let's start with the x-intercept. So just set the top equal to 0. So we get x equals 0 if you cube root it, which means if you can guess, if you plugged in 0 in there, then the y-intercept is also going to be 0. Oh, that's nice. Okie dokie. Holes. Well, let's factor here. Top, it's not factorable. But the bottom one is dots. So we get, so on the bottom we have x squared minus 1 times x squared plus 1. But we can still break this down more to give me x plus 1, x minus 1, and then we have x squared plus 1. Okay, so as you can see, nothing cancels with the top or the bottom. So there's no holes. So that means whatever is left on the bottom, it's going to be vertical asymptotes. So we have x plus 1, x minus 1, square plus 1. Set each of these equal to 0. Boop, boop, boop. So we get x equals -1, x equals +1, and then x squared equals -1, which, that's strange. We would get an I. That's imaginary, meaning that does not happen. Okay, cute. So let me just start graphing here. Make sure we have some things taken care of. So I have a vertical asymptote of -1, vertical asymptote of +1. I have an x and a y-intercept of 0. Okay, so now let's see our horizontal asymptote. Okay, so this one is bottom heavy because the degree in the bottom is bigger than the degree on the top. So when you're bottom heavy, your asymptote hits the ground. The ground there is the x-axis. So the horizontal asymptote is y equals 0. So this is going to be a special one, loves, because right now we have an intercept on top of the, on top of an asymptote. Usually that doesn't happen. Well, it could happen, right? Usually we've seen it with vertical asymptotes. But with this, because there's no other y-intercept besides that, it's going to look a little different. So let's just plug in some numbers to the left and to the right of -1 and 1, just to see where those land first. Okay, so I'm going to say -2, I guess. So if I plugged it into the original, -2 cubed over -2 to the 4th minus 1. So -2 cubed is -8. 16 minus 1 is +15. So that means it's going to be taking place down here. Okay, and actually, this goes a little bit closer. Oops, I didn't mean to. So -8/15 is like right here. So I don't know why that's so large and in charge, but here we are. Oh, like that, something like that. Okay, it'll look something like that. So now let's see at +2. So if we plug, I don't know what just happened. Sorry. I hope I didn't scare you. Okay. Okay. At +2, so we have 2 to the 4th minus 1. So we have +8 and a +15. So this actually takes place like here. So this looks like this. Interesting. Okay. So now if we were to plug in this whole thing into our calculator, let's see what that would look like. Okay, my love. So if I were to plug this into the graph, let's see what it looks like. So control divide, cubed, x to the 4th minus 1. So look at this. Okay, this looks exactly how we graphed the other parts, but this actually goes through. Oh, can I do this? Oh, there we go. So this actually makes like a little S. Okay, so really the only times that you see this happen where the function does cut through the asymptote is generally when it's bottom heavy. Okay, because I'm not exactly sure the reason why, but that's the only ones that I've seen that actually cut through the asymptote. And I've actually never checked here at the table. So if you go up to, so look at, that's actually a point on there, the 0, 0. So it's because that it's not actually undefined at only that point. Okay. When we plug in 0 in, we can clearly see that we get a 0. We get an output. So generally, if it wasn't a point, when we would plug it back in, it would give us like undefined. But this one, because when we plug it back in, you actually get an output, it can be a point on there. Okay. Like I said, we'll do more practice tomorrow and the rest of this week, but I miss you all and I can't wait to see your faces tomorrow. Have a great day.